Differential Calculus Grade 12 Mathematics Paper 1. Right, as usual, differentiating from first principles. We know that our formula says that given f of x, the derivative of f of x is equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. This is our expression. This is the formula we need to use. Now, what it means for us is that we are going to take our expression that we have, f of x plus h, means in our expression, in place of x, we're going to substitute x with x plus h. You follow through the entire expression, replacing x with x plus h. Then minus f of x. F of x is our original expression, which is minus 2x cubed plus 6x. Please remember, when you subtract more than one terms in maths, it is advisable to put brackets so that everything at the end is subtracted. So this is my substitution. Now, if we look at this expression, notice that from the beginning here, right through until here, that is f of x plus h. Then this last part is f of x. So this is f of x plus h minus f of x. So once again, f of x plus h means you are replacing x with x plus h. Then you simplify the resulting expression. Now, we know from algebra that x plus h cubed means x plus h, factor of x plus h, factor of x plus h. That is x plus h cubed. Then the second one, 6 factor of x plus h, can be simplified to become 6x plus 6h. Then the next one, negative and the negative make it positive. So that is positive 2x cubed. The 6 becomes negative. That's minus 6x. We are basically simplifying our expression over h, and h is approaching 0. Then carrying on, these brackets that we have here, we're going to keep the negative 2 outside. You can multiply directly, or you can do 2 brackets at a time. So if we do that, then I'm going to keep the first 2 minus 2 and x plus h. Then I multiply the next 2 brackets to get one expression. So if you use the FOIL method here, x times x, x times h, h times x, h times h. Do that multiplication first. This is just a suggestion, it's not a requirement. You can multiply it in your own way, but what's important is that we need to remove these brackets and simplify the expression. So that's going to give me that expression after simplifying them. Then this whole part has got plus 6x plus 6h plus 2x cubed minus 6x. Then this is all divided by h as h approaches 0. Then carrying on, now I can multiply the second set of bracket that I have to complete my FOIL method. So from here, I've got x times x, x times that, x times that, this times that. I multiply there, and I multiply there. In a simplified form, I'm using the FOIL method to do this. So in simplified form, this is going to equal the limit of the negative 2. Please take note, the negative 2 is still outside. because it's going to multiply everything after removing the brackets. So this will give me an expression x cubed simplified. This is basic algebra once again, plus 3x squared h plus 3x h squared plus h cubed. Then I close my bracket. Then these other terms, I am able to notice from these expressions that I can actually get 6x minus 6x, that is equal to 0. So those two can subtract each other to give you 0. Then I'm left with plus 6h plus 2x cubed. This is all divided by h as h approaches 0. Then after that, I can now multiply by negative 2. So this is equal to the limit, a negative 2, multiply 1 by 1 all the way until you finish these expressions. We're going to have minus 2x cubed, then minus 6x squared h minus 6x h squared minus 2h cubed plus 6h plus 2x cubed, then divided by h as h approaches 0. Now, when I get at this stage after simplifying my expression, you can do a quick check to see that your answer is correct. The original terms that are in your expression, they must subtract each other. So remember, in step 1, 2, 3 backwards, we got plus 2x minus 2x. Now here we are left with 2x cubed. So if you look at this 2x cubed and that 2x cubed, they become 0. And when the 2 become 0, the remaining terms must all have a common factor of h, because after this you are now going to factorize h. If h is not a common factor, then it becomes impossible to factorize, and that means we won't be able to find the answer anymore. So take out h as a common factor from this expression. Is going to give us the limit of h, then factor of 6x squared minus 6xh minus 2h squared plus 6. I have factored out h from the whole expression. Then the h that we have factored out is going to divide the denominator. Then the h that remains in our expression becomes 0. So if you look at this whole expression, the only two terms that are going to remain here are a negative. There is a negative. I just forgot the negative here. We are going to remain with a negative of 6x squared and then plus 6. That is our answer for this expression after factorization using first principles. So with this kind of a question, just be careful, especially with brackets and negative numbers. Otherwise, it is not different from other expressions that we have been factorizing using first principles. Right, number 3.2.1. After first principles, we get questions where we must differentiate using differentiation rules. So here we are given an expression 2x squared plus 1 over 2x to the power of 4 minus 5 root x, then minus 3 over x. Now, important, We have discussed this in a lot of videos. When you are differentiating using differentiation rules, we need to take notice of few ideas. Number one, make sure that there are no square roots. If a square root is appearing in that expression, then we must change the square root using the laws of exponents. B root x to the power of a is the same as x to the power of a over b. Secondly, if there is a variable in your denominator, change that denominator using the laws of exponents. So let's say, for example, I have a over x to the power of n. This is a x to the power of negative n. Then that is two things. The third one is brackets. You must make sure there are no brackets. In this case, there are no brackets. So we're just going to take care of the square roots and the variables that are in our denominator. So from there, our expression becomes y is equal to 2x squared plus, please take notice, in the second term, this is 1 over 2. The 2 does not change. There are some learners who end up writing 1 over 2 as 2 to the power of negative 1. While this is correct, it is not necessary to do. We keep 1 and the 2 as one number. It's a fraction 1 over 2. That is our coefficient. Then this x to the power 4 changes into x to the power of negative 4. We have applied the law of exponent to change it. Then the third term, 5 times root x, we're going to change that square root into 1 over 2 as our exponent. So this is 5x to the power of half. Then in the last term, we move that x, it will become x to the power of negative 1. This is the important part. We have not yet differentiated this expression. We have just simplified it to make sure that it is now possible to differentiate. If you go back to your differentiation rule, it says that if you are given f of x is equal to a x to the power of n, then the derivative of x is equal to a x to the power of n minus 1. So this is a n to x to the power of n minus 1. So this process of making sure we simplify square roots, we simplify denominators, we do it so that we may be able to clearly tell what is a, or what is the coefficient, and what is the exponent in our expression. So this is the coefficient, this is the exponent. This is the coefficient, this is the exponent. This is the coefficient, this is the exponent. A coefficient and exponent. Then to now complete our answer, the answer is exponent times coefficient. So that is 2 times 2, it gives us 4x. Then the new exponent is n minus 1. Then we carry on, minus 4 times half. We get minus 2x. If you minus 1 from minus 4, it gives you minus 5. Then half times minus 5, it gives us minus 5 over 2, or 2,5x. And then half minus 1, we get minus 1 over 2. Then negative 1 times negative 3, that will give us a positive 3x to the power of negative 2. This is our answer. In some examination questions, they specify that you must leave your answers with the positive exponents. If they say you must leave your answers with positive exponents, then that is an instruction that you must follow. It means these negatives, they become fractions with the positive exponents using the laws of exponents. So this is 5 over 2, then x to the power of 1 over 2. The last one is 3 divided by x squared. We have answered number 3.2.1, differentiation using differentiation rules. Number 3.2.2, the same thing applies. We have f of x is equal to x cubed minus 5x squared plus 4x. Then from there, we want to differentiate this. We can't have variables in your denominator. And please take notice. If I get 2, I'm just giving as an example, over x, I can write this as 2x to the power of negative 1. That's what we were explaining above. But if I get 2 over x minus 1, there are some learners who end up having 2, then they write 2 to the power negative 1 and 1 to the power negative 1. Please never do that. It is not correct. If your denominator has 2 terms, it means you must use factorization to simplify your answer. So if you look at the top one, there is a common factor x. So if you factor out x, you're going to get x squared minus 5x plus 4, then divided by x minus 4. Still after that, we can see that in brackets we have a trinomial that we can factorize into 2 more brackets. So factorizing again, that would be x minus 4 factor of x minus 1 divided by x minus 4. After factorization, then you divide the common factors. The 1 at the bottom, x minus 4, divides the 1 on top, also x minus 4. Then the x that remains and the x minus 1, you multiply them, x times x and x times 1. Because remember, we don't need brackets when you are doing this. So this is going to give us x squared minus x, and this is f of x. Let's notice that in all this we did not differentiate. We have not yet differentiated. We have just simplified the expression to make it possible to differentiate. After this, we can now differentiate. So the answer is 2x minus 1. We have differentiated number 3.2.2. So important is to remember the method applicable. There are 2 terms in your denominator, and what does that mean for you? It means you must use factorization. You factorize the expression. After factorizing, you divide common factors and then carry on to simplify and then differentiate. That answers number 3.2.2. Right, number 3.3. This is one of the common questions that we meet under the calculus section. The equation of a tangent. So here they ask you to determine the equation of the tangent, or they give you the equation of the tangent and ask you to calculate certain values. So let's see how to go about answering this type of equation. Important for us to know before we go on is that when determining the equation of a tangent to a graph, you need 2 items. The first one, you definitely need the gradient of that tangent. Now, how do you find this gradient? The gradient is the rate of change. The rate of change is the derivative. So, what we do is that we differentiate the equation of the function that we have. And after differentiating, we now have an expression. Basically, the derivative is the gradient. The derivative is the rate of change. Therefore, it is also the gradient. So the idea to keep in mind is that the gradient of the tangent and the gradient of the curve, they are equal at the point of contact. The gradient of the tangent and the gradient of the curve, they are equal at the point of contact. So you differentiate your expression. I have just differentiated here. Then after differentiating, we can now say the gradient at x is equal to, we are given the point of contact here, the coordinates of the point where the line is touching the curve. It's at 2 and 3. So the gradient at x is equal to 2. In the derivative that you got, you substitute x with the x value at which the line is touching the curve. So in my case, it's going to be 2. So this is 4 times 2 minus 3. That gives me 8 minus 3, which is equal to 5. This is the gradient of the tangent. This is the gradient of the tangent. Now, what we need now is to determine the equation. In this case, the question is talking about a line which is parallel to the tangent. The tangent has gradient 5. Parallel lines have equal gradients. So the gradient of the tangent, which is equal to 5, is also the gradient of the line that we need, because parallel lines have equal gradients. Now, if I were to change the word parallel here and put the word perpendicular, then you will need to know that the product of the gradients of perpendicular lines is equal to -1. So after getting the gradient, we have to use it to find the gradient of the line which is perpendicular to it. In this case, we want the equation of a line which is parallel to the tangent. Therefore, we are going to use the gradient of the tangent, because parallel lines have equal gradients. Now that we get our gradient, we now go on and use the standard form of a linear equation. Y is equal to mx plus c. We know that in this equation, m is the gradient and c is the y-intercept. So we're going to calculate the value of c. To calculate the value of c, you need the coordinates of the point where the line is touching the curve, or the coordinates that are mentioned where the line is passing through. This line is drawn passing through 2 and -3. So we're going to use these 2 points to find the value of c. The first one substitutes x, the second one substitutes y. So in this equation, y is equal to -3 when x is equal to 2. So this gives us -3 is equal to 5 times 2, and then plus c. So carrying on, this is a general equation. 5 times 2 is equal to 10 plus c. Therefore, c is equal to -13. After calculating c, we can make a conclusion and say, therefore, the equation of the line is y is equal to 5x minus 13. We have determined the equation of a line drawn at the point 2 minus 3, which is parallel to the tangent to the graph that is given. That is the answer for question number 3.3. It's very much necessary to definitely know how to handle this kind of calculations, because I have seen them in so many examination papers. You need to know this idea of tangent, how to go about it. Number 3.4 is on the same thing, the tangent. Now let's have a look. No, it's not on the same thing. It is given that uh, g of x is equal to ax cubed minus 24x plus b is a local minimum point at minus 217. Determine the values of a and b. So number 3.4 is slightly different. But let's have a look at how to calculate it. When you approach this kind of a question, number one, if you are given coordinates on a graph, those coordinates, they satisfy the equation of the function you are given. So y is equal to ax cubed minus 24x plus b. Then in this equation, this graph, the graph has a local minimum point at minus 2 and 17. It means the graph is passing through minus 2 and 17 basically. Whether it's the local maximum, minimum, it doesn't matter. As long as the point is on the graph, the same idea applies. So y is equal to 17. Then x is equal to negative 2. So my equation is a x cubed. So I'm going to take out the value of x and substitute with negative 2. So that will be a x cubed now become a then minus 2 cubed. So this is basic substitution that we are doing. Then substitute the value of x throughout the entire equation. And then after that we simplify. So once again, what are we doing here? When given coordinates on a graph, or when told that a graph is passing through a certain point, and we are given the coordinates of that point, then we can substitute those coordinates into the equation. They satisfy the equation of the graph. So that's what we are doing with minus 2 and 17 here. So y is equal to 17 and x is equal to negative 2. Then we simplify the equation until it is in its simplest form. So 17 minus 48, and putting the integers together, that will give us minus 31 is equal to minus 8a plus b. Now, at this level of maths, if you have an equation in two variables, then you can keep it at the background of your mind that these are simultaneous equations that we are going to solve. So, to make it easier for us, we can as well make a or b the subject. So, b is equal to minus 31 plus 8a. Or you may want to say b is equal to 8a minus 31. It means the same thing. This is our equation 1. Where did we get this equation? We said if you are given coordinates where the graph is passing, we substitute those coordinates into the equation given and simplify. Idea number 2, which is absolutely necessary to understand in answering this kind of questions. We are given a local minimum point. For a graph, the local minimum comes from equating the derivative to 0. The local minimum or the local maximum or the turning point, all those terms, they mean the same thing. The turning point of the graph, they come from equating the derivative to 0. So differentiate this expression, and after differentiating, equate the derivative to 0. So my derivative is 3a x squared minus 24. Then we equate the derivative to 0. 3ax squared minus 24 is equal to 0. When we equate this to 0, We now substitute x with the x coordinate of the stationary point. So the stationary point that we have is -2. We're going to substitute x with -2 and simplify this expression. So 3ax squared will become 3a times -2 squared minus 24 is equal to 0. Then we simplify going forward. -2 squared is equal to 4 times 3, we get 12. So this is 12a minus 24 is equal to 0. Then from there, 12a is equal to 24. Basic algebra, I'm solving for a and dividing both sides by 12. A will give me the value of 2. Now that we have calculated the value of a, you now need to find the value of b. And to do that, we go back to our previous first equation that we got. B is equal to 8a minus 31. A is equal to 2, therefore b is equal to 8 times 2 minus 31. So you can simplify this with a calculator maybe, but even without a calculator you can still simplify it and get your answer to the question. Then once you do that, you have worked out the answers for number 3.4. B is equal to -15. Then our question is answered for number 3.4. So let's quickly have a quick summary of number 3.4 especially. Now we are told that these coordinates -2, 17, these are coordinates of a local minimum point. Then the local minimum point, we get it from equating the derivative to 0. So you equate the derivative to 0, and then in that equation we substitute x with the x value of the turning point, which is -2. That's what we did here at this point. We differentiated. The derivative is equal to 3ax squared minus 24. Then we equate the derivative 3ax squared minus 24 to 0. And in that expression, we substitute x with -2. So this x squared here now becomes -2 squared, which is equal to 4. So the 4 that we get from here times this 3, 4 times 3 is equal to 12a minus 24 is equal to 0, and that helps us determine the value of a, which is equal to 2. That is one idea that we have used. If you are given the coordinates of the turning point, you differentiate, equate to 0, and replace x with the x value of the turning point to create an equation. The second idea that we have applied in solving this problem, we are given coordinates of the turning point now, and we said that the graph is passing through that point. So both coordinates satisfy the original equation. X is equal to -2 in the original equation, and y is equal to 17. That is what we did. So 17 is equal to ax cubed. In place of a, we have -2 minus 24x. In place of x, we have -2. In place of x, we have -2. Then we simplify. So -2 to the power 3, we get -8. The first one gives us -8a, -24 times -2, we get plus 48. Then from there, we simplify this expression until it is in its simplest form. Then we can create an equation for b. Then after that, we go on and solve our two equations simultaneously. That's number 3.4. We definitely need to know how to work out this kind of questions. They are very much common in our examinations. So we have answered this whole question for differential calculus. I expect that this is, I believe these are easy marks that we can get if we can just do a little bit practice to make sure that we have a good understanding of how to answer these kind of questions.